Hi students, today we are going to look at the problem best time to buy and sell stock. It's a classic example of how to use programming to optimize real world scenarios. First, let's understand the problem statement. So the problem statement says we are given an array prices where prices of I represents the price of a given stock on the ith day. That means prices of 0 is the price of a given stock on the first day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell a stock. That means you can't short the stocks. You have to buy before you sell. So, and you can only sell once. You can only buy once and sell once. So what should we return? Return the maximum profit you can achieve from this transaction. We have to find the maximum profit we can achieve from this transaction. If no maximum profit is possible, the default answer should be 0. Okay. So that means we are given an array of numbers which represent the stock price. We have to pick a date on which we can sell the stock and a future date in which pick a date in which we can buy the stock and a future date in which we can sell the stock such that we get the maximum profit. Okay, let's look at the examples given. Here we are given an array of 7, 1, 5, 3, 6 and 4. The answer says the output is 5. That means the maximum profit we can achieve from this array is 5, which is from the combination of 1 and 6. So you buy a stock at 1 and sell at 6. Notice that we have 7 which is bigger than 6. But this can't be considered because 7 is before 1. Okay, we have to sell the stock after buying. So we have to sell the stock after the minimum value. And there is no such value which gives us maximum profit. For example, 3 is also less, but 6 minus 3 is only 3. Okay, here this is the only one which is giving the maximum profit. That is why that is the answer. If you look at the second example, 7, 6, 4, 3, 1. It's a descending array. So at whatever point you pick to buy, you can't sell because the stock is continuously decreasing. Which is why the maximum profit is the default value, which is 0. You can't buy or sell this stock. Okay. Now to solve this, we will go through two approaches. The first one is a brute force method. So let's consider this example for that. So here we have an array 3, 2, 6, 5 and 4. Okay. So at every point, if we consider that this is the current minimum, we have to find a point in the rest of the array which gives us the maximum profit. Okay, so clearly we will need two loops. So in the first iteration, let's say I equal to 0, we are starting at the rest of the array, right? So j should start from I plus 1 and j should go till n. N in this case is 0, 1, 2, 3, 4, 5. Okay, n is 6. So j will go from I plus 1 to 6, which is 1 to 5. So at each position, we will compute the max profit. So initially, we will assume that the max profit is 0. Okay. Then in the 0th iteration, our min or the buy point, the place where we buy, if we consider we buy at this point, our buy point is 3. Okay, and if j is at 1, then the profit is you are buying at 3 and selling at 2. J is your sell point, I is your buy point. Okay, so you are selling at 2 and buying at 3, so the profit would be minus 1, which is less than 0, so this won't change. Then j goes to 2. Okay, here the profit would be 6 minus 3. Okay, 6 minus 3, which is 3. 3 is greater than the current max profit, so we will update this value with 3. Okay, next j goes to 5, so the profit would be 5 minus 3, which is 2. 2 is less than 3, so no updation. Next value is 0. 0 minus 3 minus 3, no change. 3 minus 3 0, no change. So at the end of first iteration, if 3 is our buy point, the maximum possible profit we can make is 3, which is 6 minus 3. Now if our iteration I is at 1, which is our buy point, that means our buy point is 2. We are buying the stock at value 2. Okay, then j goes from I plus 1 to 5. Okay, so we have to sell only in the future, that is why j goes from 2 to 5, which is from here to here. Okay, so at j equal to 2, the profit would be, j equal to 2 means the actual value is 6. 6 minus 2 is 4. 4 is greater than the current max profit, so we will change, we will update the max profit to 4. Okay, next j goes to the next index, which is 5. Our buy point is still 2. 5 minus 2 is 3, which is less than 4, no change. Next value 0 minus 3 is minus 3, no change. Next value 0 minus 2, sorry, is minus 2. Okay, next value is 3 minus 2, which is 1, no change. So at the end of this iteration, we have the max profit as 4. Now if we move to the next iteration, which is I is 2 and j is 3 to 5. So our buy point is, okay, our buy point is, what is the value of our buy? I equal to 2. So 0, 1, 2, buy point is 6 and j value is 3. So 5 minus 6, the profit would be minus 1. So no change. The next value would be 0 minus 6, which is minus 6. Again no change. 3 minus 6, which is minus 3. Again no change. Okay, so in the next iteration, I is at 3 and j goes from 4 to 5. Okay, so our buy point here is 5. So we are buying the stock at 5. Now if we are selling at 0, it's a negative. If we are selling at 3, it's still negative. So the max, our current max profit is 4, so no change. Okay, now if the iteration I value is 4, okay, so j value can only be 5. So our buy point is 0 and we will be selling at 3. So 3 minus 0 is 3 minus 0 is 3, which is still less than our current max of 4. So we will not update the max profit. So out of all the iterations, our value or our result is 4, which is 6 minus 2, these two numbers. Okay, let's try and write code for this approach and see how it performs. Okay, so here is the problem on Leetcode. So what were we doing? We were first considering max profit as 0. So initially it is 0 when no operation is possible, and we are going from I equal to 0 to I less than prices dot length I plus plus. J starts from j equal to I plus 1, j less than prices dot length j plus plus. What are we doing? If prices of j. So our buy point here is prices of I, and prices of j is our sell point. So prices of j minus buy point, okay, that is our current profit. Let's write it that way. And current profit equal to prices of j minus buy point. So we have to update max profit if current profit is greater than the max profit. We will just use math.max for that. Current profit, whatever is maximum, we will pick that. Okay, and we return max profit. So we have a variable max profit which is initialized to 0. At each point I, that is our buy index, we consider the buy point. Each point j, this is our sell point, and we compute the current profit. If the current profit is greater than max profit, we update max profit with that value. Let's run this and see. Okay, let's try to submit. So it's saying time limit exceeded. So this one failed for bigger input. When they gave a huge input, it failed. So let's check the time complexity of our solution. Time complexity is, here we are traversing the array twice clearly, right? So it's order of n square. Whenever there is nested loops, it will multiply the time complexity. We are not using any extra space, just a constant of max profit, nothing in the multiples of inputs. So the space complexity is order of 1. So this order of n square is really bad when array size is huge. That is why it failed. Okay, now let's try and optimize this. Okay, so we have the same input. Let's try a different method with it now, which can be a little bit optimized. So earlier what were we doing? We were assuming every point in the array is a buy point and computing max profit for it. So anyway, our buy is going to be in history and we can only sell in future. So what if we also maintain the buy point like max profit? So we were initializing max profit to 0 and keeping track of the overall profit, right? Like that, if we also keep track of the buy point, okay, what can be the best buy point basically, then that will help us reduce one array loop. Okay, so initially when we start with, let's consider our buy point to be array of 0, which is 3. Okay, now since this is the buy point, we will start from here. So in the first iteration, we only have one loop here, I is 1, and at this point we have two decisions to make. If this can be the new buy point, when can it be new buy point? If it has lower value than the current buy point. Okay, so 3 is less than 2, so it can be the new buy point. So we just update the buy point in this iteration. So in the second iteration, when I equal to 1, okay, we are here. So we have to check again if this can be the new buy point. Can 6 be the new buy point? 6 is greater than 2. So 6 can't be a buy point. You can't buy at a higher price, but you can sell at a higher price. So 6 can be a sell point. So if you sell at 6 and assuming you bought at the buy point 2, what will be your profit? It would be 6 minus 2, which is 4. Our current max profit is 0. 4 is greater than 0. So we have to update max profit with that value. Okay, in the third iteration, when I is 2, we are here at 5. Okay, can 5 be the new buy point? No, because 5 is greater than 2. Can 5 be the sell point? Maybe, possible. Let's check. So if 5 is the sell point, what will happen? We have to compute the profit. Profit is 5 minus the current buy point, which is 3. 3 is less than 4. So 5 can't be the buy point. Okay. Now in 4, when I equal to 3, our buy point is 2 and the current value is 0. Can this be the new buy point? Yes, it is lesser, so it can be. So our buy point becomes 0. Okay, it's a buy point, so we can't sell at the same value. Okay. Now when I equal to 4, we are at 3. So is 3 less than the current buy point? No. Current buy point is 0 and this value is 3. So 3 cannot be a buy point, but 3 can be a sell point. So if 3 is a sell point, what will be the profit? Profit would be 3 minus 0, which is 3. So is 3 greater than the current profit we have? No. Our current profit is bigger. So our profit will still be 4. So 4 is our answer. Okay. Let's see the same thing with another example. Let's say we have an array like this: 7, 4, 3, 2, 1. Okay. So here in the first iteration, I equal to 0. Okay. And we have two variables to initialize. One is max profit, which is initialized to 0, and buy point, which is initialized to array of 0, which is 7. So our array starts from 1. So this is our buy point. We start from here. So when we are at here, what we check? Whether the current value is less than the buy point. If it is less than the buy point, it will be our new buy point. 4 is less than 7. So at the end of this iteration, our buy point will change to 4. In the second iteration, when I equal to 2, we are here. So the current value is 3. Is it less than the buy point? Yes. So our new buy point would be 3. In the next iteration, when I equal to 3, okay, our current value is 2, which is less than the buy point. So our buy point will change to 2. Okay. In the next iteration, the current value is 1, which is less than the buy point. So our buy point will change to 1. Okay. In the next iteration, current value is 6, which is greater than the buy point. Now we have to check if this can be a sell point. When can it be a sell point? If we make profit more than the current max profit. So 6 minus buy point 1 is 5. Okay, is this greater than 0? Yes. So our max profit would be 5, and this is our answer. So here, by keeping track of the current buy point or the current lowest value, we eliminated one loop. Okay, this is called the peak valley method. We are basically finding the lowest point and the highest point after that. Let's try and write the code for this. Okay, so in addition to max profit, now we also keep track of buy point, which would be prices of 0. So here you have to remember that we are assuming that the array will have a size of 1 always, which is guaranteed by the constraint here. It is saying prices.length is greater than or equal to 1 always. So we can safely do this. If the array can take size 0, then we have to add a condition check here and not do this. Otherwise we will get array index out of bounds exception. Okay. So here array of 0 is already taken care. We are starting from I equal to 1 to prices dot length. We are maintaining the buy point globally. We don't need this loop. Okay. So again our current profit would be prices of I minus buy point, and max profit would change to, no, we have to update the buy point as well. We have to check if this value can be a buy point. Prices of I is less than buy point. Okay, then buy point equal to prices of I, else this is what happens. Okay, else our current profit would be prices of I minus buy point, and max profit would be maximum of both the profits. Okay, so if it is a buy point, it will be here. If it is a sell point, it will come here. Let's run it and see. Okay, the sample test cases pass. Let's see if the submission works now. Yeah, so it just took 1 millisecond to complete. Okay, so what is the time and space complexity of this solution? Here we are only going through the input once, so it's clearly order of n. Okay, what is the space complexity? Here we took two variables, but still it is constants, so it is order of 1. It's one variable extra than the previous one, but it is not in the multiples of input, so it's still a constant, so order of 1. So the space complexity of this solution is order of 1. Okay, so we have successfully explored the best time to buy and sell a stock problem. We discussed two different approaches to solving it. I hope you have found this video informative and insightful. I encourage you to solve the problem yourselves. Only when you practice, you will get to know the problem better. If you found this video useful, please give a thumbs up and subscribe for more coding tutorials. Thank you so much for joining us today. I truly appreciate your time and dedication to improving your coding skills. Until next time, happy coding.